I'm a contributor at Keda, which is a CNCF incubating project, and I've been contributing to Keda for about 6 to 7 months now. Feel free to connect me with on LinkedIn or GitHub. Moving on, this is our agenda. So here we have, as the title suggests, HPA low scale esteem. Now why the title? To know about that a bit, we would want to know what is HPA. So HPA is basically a component of Kubernetes, which allows you to scale your deployments or replica sets, or any kind of stateful set based on kube metrics, server metrics, such as CPU, memory, or network I/O. But why I have written here low scale esteem? There's a reason for that. So it allows you to scale based on very primary elements, such as CPU, memory, but what it doesn't allow you is to scale on real life events, such as when you have too much user traffic in your app, or your database is filling up, your queue is filling up, things like that. HP is not able to handle those things. So here the question is, why isn't the queue metric server enough? Is because you don't have any capability, or it doesn't have any capability to scale based on custom events, as I mentioned. So how does Keda help here? So to explain that, I would like to give a simple use case. So let's say we have an e-commerce platform, and obviously you have many deployments and as well as instances running the application. Now on days like Big Billion Days or holiday sale, or let's say Good Friday sale, a lot of users come. No matter for how much of a limited time, it will increase the traffic to a very good amount, which your application might not be able to handle, because from before you can't predict that, let's say, how much your databases will fill up, or how much your queues will fill up, or your caches. So how Keda helps in this is exactly, you tell Keda that we have this event. So let's say the databases have the number of documents. If it increases greater than 10 in one instance, then you tell Keda that scale up to, let's say, 4 instances. So what Keda will do is, it will take that particular event and feed it to the metrics adapter, which is a part of Keda architecture, which we will go ahead and see. And it will basically, the metrics adapter will tell HPA to increase the replicas. And how does Keda help here is, it has the capability to scale to 0. That is, you can literally have 0 amount of workload running when you don't need it, as well as it makes it possible to scale workloads based on any event you can think of. So it can also be integrated with monitoring tools such as Grafana. And moving on, some of the features of Keda. So Keda has, as it says, auto-scaling made simple. Now why? Because as it brings very rich scaling to your applications, you can basically scale based on any event possible for your applications. It's event driven because again, you can scale it based on any event that your application needs. You're just not limited to CPU or memory or network. It has built-in scalers. It has over 50 plus built-in scalers, which includes Azure Q, Prometheus, RabbitMQ, Kafka, and so on. Multiple workload types. You can not only scale your deployments or stateful states, you can also scale up jobs and any other custom resource. Fourth is the reduce environmental impact. Is basically it helps you to build workload scheduling very nicely, because it has the feature of scale to 0. And why it's extensible? Because you can easily write your own scaler from the Keda community, which has a very nice documentation written. Now coming to the architecture of Keda. So here we can see that up above is the Kubernetes API server. So this basically listens to the Keda controller, which you can see in the blue box. And beside, on the left side, is the metrics adapter. And on the right side is the scaler and the admission webhooks. The scaler is basically the scaler that you've written. It can be any database scaler, any queue scaler, or any cache scaler. And admission webhooks basically checks that if the custom resource is defined under the controller, whether it has been written properly or not. And so how does the metric adapter connect to the HPA? So basically the controller listens to certain custom resources which are defined when you deploy the controller or your scaler. And it converts the metrics to such a form which can be fed to the horizontal pod scaler. And now here you can see the yellow line, that the horizontal pod scaler only scales from 1 to n, or scales down from n to 1. Various, the 0 to 1 and the 1 to 0 feature is done by as part of Keda. Plus, on the right corner, you can see external trigger source. So not only you can scale your resource based on any built-in scaler, but you can also trigger the any kind of scaling decision from using a gRPC endpoint. It can be any database, whether Oracle database or any kind of HTTP workload. You can use the external trigger source to do that. So coming to the concepts of Keda, on the right side code part, you can see that this is a scaled object and this is deployed as part of the Keda custom resource definition. And this is mainly for deployment stateful sets or replica sets. As you can see that you can also define multiple scalars. So in the trigger section down there, you can see type scalar name. That's an array. So you can define as many scalars as you want. Next, you can see features such as polling interval. So what is polling interval? Polling interval is basically after how much time do you want your scalar to see if any event has been triggered or not. Next comes the cooldown period. So let's say you don't want to go and manually check and see that, okay, the workload is down, the traffic is down right now, let me just scale it down. Instead, you can just put a cooldown period and Keda will automatically scale it down. Let's say after, by default, it's 300 seconds. Then ideal replica count. So this basically tells you that when no activity is there, just a normal user traffic day, how many replicas should it be running? Fallback replicas, let's say due to any disaster, natural or man-made, if it happens that application is down and Keda is not able to retrieve the metrics from that scalar, it will automatically scale back it to the fallback replicas, which you can define in the down under fallback. And the failure threshold here basically defines that, let's say I'm not able to, or the Keda is not able to get the metrics for, let's say 3 times or 4 times, then it will scale the replicas to 6. Now coming back to trigger, as I said, the trigger defines all these scalars that you are mentioning and you want Keda to watch events for. So trigger basically defines all the scalars name here. There's also a feature of autoscaling. So in the autoscaling annotation that is given here, autoscaling.keda.sh, you can also pause the autoscaling whenever you want to. Plus, apart from this, you can also put your self-signed certificates or your own certificates when you are deploying Keda metric server. There is another custom resource that is scale job. Now, why scaled object? And we already have it for deploying things, then why scale job? Scale job is basically for events or for jobs that are very short-lived, and you kind of want it to do something and then end it. So for those specific jobs and workloads, we have scaled job. As given here, it has this job target ref, how many parallelism you want, how many active deadline seconds you want. All of this are given in the Keda docs, which are explained in this doc here. I don't think it's coming. Yeah, and the rollout strategy here tells that in which way you want to roll out your jobs or workloads. The last custom resource is the trigger authentication. This basically, so it's not needed that you will always give the parameters in your trigger section. You can also differently configure custom resource for giving all your credentials to the scalar. So trigger authentication resource allows you to do that. There is also something called cluster trigger authentication, which can be just basically a single set of credentials which you can share between many scalars that define under the triggers. As well as you can also use this particular trigger authentication resource as many times as you want. So coming to demo, just a context before the demo. This demo I will be showing basically a RabbitMQ queue, and I will be publishing some messages to the RabbitMQ. And as we know, soon the queue will be running out of space and we don't want that. So I will be spinning up some, I will spin up a target, basically which will be the RabbitMQ consumer, and Keda will be configured that whenever, let's say, the message queue length is more than 10, then it will scale it to the maximum number of replicas. So So I have Keda running here. As you can see that the operator, the webhook as well as the metric API server is running here. And we will now try to first deploy RabbitMQ. So as we can see that the deployment, the config maps as well as the services are deployed. If we go to the namespace, so we can see that RabbitMQ is running, and now we will go ahead and see the scaled object. So I am deploying a scaled object which basically has the scale target ref of this YAML which is defined here. So this is basically a RabbitMQ consumer which is being the target of scaled object, and the polling interval, that is after how much time the Keda will check whether there is a trigger or not. It's 5 seconds. The cooldown period will be 10 seconds, that is after 10 seconds Keda will check that if there is no activity then it will scale it down to 0 replicas, which is given here as the min replica count. As well as the max replica count is 5, which is max up to 5 Keda will scale the workloads. The trigger's name is RabbitMQ because the scaler is RabbitMQ here. The metadata, the queue name is hello. The host from environment, there is a secret defined here in the target YAML. And you can see that I'm using the base 64 encoded version of the host name of the RabbitMQ that is running. And from protocol, I'm using HTTP. I'm not using AMQP here. Mode is basically what event you want to monitor and trigger the workloads. So I'm using the queue length, and what is the threshold value? It's 10 here. And this is my target, which is basically a simple RabbitMQ consumer. And this is the secret. This publish.yaml is the main job, which basically publishes about 100 messages to that particular queue in the given host name. And the queue name is hello. So we will go ahead and apply the scale job and target. So as we can see that it's been created. So if I go to the test namespace now, which contains the target, so you can see that the deployment RMQQ HTTP test deployment is 0 because nothing has been triggered yet. And in the last, you can see the HPA where the average, the targets are 10. So right now it's unknown because no message has been pushed to the queue yet. So if I now go ahead and apply the publish.yaml, so you can see that it's created. So if you now watch for some time, you can see that the HPA takes some time to update it, but you can see that there is already a container running here. Let's give it some time to scale it. So you will see the number of targets. You can see that 91 out of 10. So that means it has crossed 10. And already we can see that it's consuming the messages because we can see 4 replicas of the deployment here. Now we can see that the 5th replica is also coming. 11,500 M here just means that it's 11.5 messages are right now in the queue. Why? Because all of the messages are being consumed by the pods that you can see in the replica. And now why did it terminate? Because while it was coming up, it had already completed 10 seconds, which was the cooldown period. And therefore for 10 seconds, it didn't see any activity, and therefore it scaled down to 0. You can always refer the Keda docs in the references given. And to know more about the scale job and as well as scaled objects, you can always go to Keda.sh docs to see the spec and all the details of the parameters. Yeah, and that's it from my side. If anyone has any questions, they can.
Thanks for the talk. My question is about scaling to zero. You
Yeah.
mentioned scaling to zero. So
Yeah.
if my application, let's say, depends on number of entries in the RabbitMQ queue,
Yeah.
does it mean that if there is no message, there are no messages in the queue, my pod doesn't need to be spun up at all?
So basically, as you saw, right, when there were no messages in your queue, when you saw the HPA targets as unknown or zero, and sometimes it comes at like that, then if you configure workloads with Keda, it would, you have to mention the min replicas, by the way. So you have to say that the min replica count that you just saw in the scaled object, you have to say to keep it zero. Otherwise, it will keep it at 1.
Okay, great. Thank you.